So, so far we have learned about triangles, that in the triangle inequality theorem, that the smallest sides of a triangle must add to more than the largest side. And so we've been checking triangles to see that the two smallest sides add to more than the largest side. If it doesn't, it can't be a triangle. If it does, it can be a triangle. Okay? Now, what happens if we're given two sides and we're asked to find the range of possible measures for the third side? Well, now this gets a little bit trickier, but we can still do it. What we're going to do is we have to think of two possible scenarios. The first scenario is that these two sides, 9 and 5, are the two smallest sides, and therefore we need to put a limit on what the largest side can be. And the second scenario is that 5 is one of the smaller sides, 9 is the largest side, and that the unknown side is one of the other smaller sides. And then what we're going to do is then we're going to find a limit as to what the lowest, smallest, the other small side can be. Okay, so let's start with the first one, which has 9 and 5 being the largest or the smallest sides. Okay, so if 9 and 5 are the smallest sides, and actually I would encourage you to write this in order from smallest to largest, just it kind of helps to visualize things. So if 5 and 9 are the smaller sides, we're missing the largest side. But we know that since 5 plus 9 equals 14, that whatever the largest side is, it has to be less than the sum of the two smaller sides. So we know now that if 5 and 9 were the smallest sides, that the largest side would have to be less than 14. Now, you notice how I didn't say 13, because technically it could be 13.8 or 13.9 or 13.99. It just has to be less than 14. Okay? Now, let's look at 5 and 9. And now we said that 5 is one of the smaller sides, but 9 is one of the larger sides. And the side we're missing is the other smallest side. Well, in that case, I know that 4 plus 5 equals 9, but I know that my sum has to be greater than the largest side. So that means that my smallest side can't be 4, it must be greater than 4. Okay? So what I've done now is now I have two scenarios. I know that whatever my missing side is has to be more than 4, but I also know that it has to be less than 14. That is a range of possible scenarios that our side can be. Okay? So what we can do is if we had a number line, we could visualize it this way. We know that it has to be more than 4. So if we think about inequalities, we're going to use an open dot because it can't be 4, it just has to be greater than 4. And we know that it has to be less than 14. So once again, I'm going to use an open dot. But anything in between 4 and 14 would work. So if we were talking about whole numbers only, 5, 6, 7, 8, 9, 10, 11, 12, and 13 would all be possible scenarios for a possible third side. Again, those are only whole numbers. Technically, 4.1 could work, or 4.01 could work, just like 13.8, 13.9, 13.95 would also work, okay? Now, you're not expected to know this, but it is helpful. Whenever we have a range of possible scenarios like this, we can actually write this instead of two separate inequalities. We can combine them to make one inequality. So we can do it this way. So we say 4 is less than x, which is less than 14. And the reason why we're allowed to do that is because if we look at this first part of the inequality, 4 is less than x, we know that that turns around to x is greater than 4. Remember when we were doing inequalities, if you want to change the order, you just have to change the sign, and x is greater than 4 is exactly what we got here. And then if we look at the other side of it, we have x is less than 14. Well, that's exactly what we have here. Okay, so it's a way to write the inequality as one separate sentence. Okay, so we don't have to worry about that anymore. All right, now Let's try one more time on this one. I'm going to go, so we have 5 and 8. It's already in order, right? So first we're going to say if 5 and 8 were the smallest sides and we're missing the largest side, 5 plus 8 equals 13, which means the missing side has to be less than 13 because the two smaller sides have to add to more than the largest side. And then if we say that the missing side was smaller, okay, now we don't know if it's smaller than 5 or not, just so you're clear. We just know it's one of the smaller sides, but we know that 3 plus 5 equals 8, so that means that 3 plus 5, it has to be more than 3, so we know that it must be more than 3, so I can then set this up as 3 is less than x, which is less than 13, or the possible values have to be between 3 and 13, okay? Now, you might be thinking, I wonder if there's a pattern that we can use to make this a little simpler, and there is a pattern that we could use, okay? If we look at these two numbers, and we look at the numbers that we generated, all we did was we subtracted the two numbers to get the low number, and then we added the two numbers to get the high number, and all of our ranges are between those two. Look here, 5 and 8. If I subtract 5 and 8, I get 3. If I add 5 and 8, I get 13. There's your pattern. There's your shortcut. So if we use that for this next one, 6 and 10, if I subtract 6 and 10, I get 4. If I add 6 and 10, I get 16, which is a shortcut to say all of my possible answers are between 4 and 16. Greater than 4, less than 16. Okay? This next one, we have 6 and 9. If I subtract them, I get 3. If I add them, I get 15, which means my possible ranges are between 3 and 15. And that makes sense because 3 plus 6 equals 9, so it has to be more than 3. 6 plus 9 equals 15, so it has to be less than 15 if 15 isn't one of the possible answers. Okay? Hopefully that helps. Now you can use this information and try to complete that IXL for extra credit. Good luck. And if you have any questions, come in and see me.